Coming off the back of races that provide valuable testing opportunities, like Barcelona and Montreal, we met up with Scuderia Ferrari chief designer, Nicola Stombazis, to find out how much the F2012 has changed and how it can evolve still further over the rest of the season, with attention focusing on the next round at the Valencia Street Circuit.
The F2012 has improved a lot in terms of performance since the beginning of the season. What's the secret behind this improvement?
Well, I would say the main secret is a huge amount of work from a lot of people, starting from the aerodynamics, the design office and all the production, where the work over the last few months has been intense. We have practically changed most of the car since the start of the season, and we have worked with determination to cover all the negative points we realized we had at the beginning, the first test. So I would say there isn't a single area, but there's been a coming together of a lot of different ideas that cover basically car from nose to tail.
A lot of work has been done on the exhaust. The layout used in Montreal was similar to the one presented in Jerez at the first test. This means that that idea, that concept wasn't completely wrong, isn't it?
Yes, I would say that the Montreal configuration is a sort of a cousin of the one we had used in Jerez. In Jerez, though, we had a probably more complicated system that we found all sorts of problems with in terms of instabilities and in terms of aerodynamic behavior, that made it, whereas it was looking promising, it was not actually converting into lap time or making the driver feel better in the corners. So that system had to be abandoned. We then spent some time in the months sort of from late February until May, concentrating on the other weaknesses of the car, there were quite a few, which brought us towards the first big step we made, which was for Spain. That had, as you know, conventional exhaust. So we basically reviewed the car in its entirety, from the front wing, the diffuser, the rear wing, all the various turning vanes, etc., and the brake ducts. So we basically changed the whole car, aerodynamically speaking. And we then, in the meantime, kept working on the exhaust and arrived at a more robust, simple system, which is what we introduced in Canada, which was another step forward.
What you can say about the next development of the car?
Well, at the moment we are reasonably happy with where we have arrived to, considering where we started from, but we're not completely happy because we're not yet able to dominate races and to win all of them as is our objective. And we also have very strong competitors who are also keeping developing their cars as well. So we feel it's going to be a race until the end of the season. That means that the work we've been doing since the first test until now is continuing at the same intensity, and we've got developments that will keep coming over the next few races. Starting with Valencia, we are going to be doing experiments on the front wing, on the floor. We're going to be having further evolutions of the exhausts, and basically following that there will be also rear wing upgrades, turning vane upgrades, so it's something that will continue, I believe, until the last race.
One of the weakest points, according to drivers' comments, for example, was the top speed. How did you operate to improve that area in the last few months?
Yeah, I mean the top speed for Formula One car the last couple of years is a bit more complicated than it was traditionally in the past, because the DRS system has changed the optimum level of CD of drag that a car has to have for a given circuit. So to improve the top speed is not a matter of just making a rear wing that has a bit less downforce and a bit less drag, like used to be the case until a few years ago. So we have had to work, of course, on the rear wing. We've made a lot of progress there and we will continue to do so, but we've also had to work on the DRS system itself and also on the drag of the rest of the car, the main car body. So it has been work on all these three areas, which has improved the matter, although not completely closed the gap to the competitors.
There was a lot of talk at the beginning of the season about the DRS system of Mercedes. Did you think about introducing that solution on the car?
Yes, we have analyzed and done work on the system. There's obviously there was initially some questions about the legality. I'm not saying the Mercedes system is illegal. It was in the sort of grey area of the rules, I believe. It was a clever design. We have evaluated similar systems, and we have found that some of the negatives of the installation of that system on a car and the benefits we can get from this system are of a roughly similar order of magnitude. Hence, the system is an interesting idea. It remains a system to be evaluated, but it's not, I would say, the top priority for development.
Personally, how did you live this last few months?
Well, as we've said various times in the past, in Ferrari we have a bit of a particular situation because we have, rightly or wrongly, an expectation that we must be winning every race and we must be always competitive. So to arrive at the start of the season with a lot of cars ahead of us and a very uncompetitive situation is a big shock for me personally and for all of my colleagues. And so it was a very hard few months. That said, we did put our heads down and we analyzed what was wrong with a reasonable amount of calm, and we therefore managed to recover that situation to a large extent. And I think the last few races have been a morale boost for most people, for me as well, and have made us believe that we can make it. And therefore I think that has become much more satisfying now to work again, because obviously it's much nicer to be watching a race when you're likely to fight for pole position or for a win, rather than wondering whether you're going to make it into Q3.
As a chief designer, you have to look not only to the next week, but also to the next future, next season. This year is different because we also have to look about 2014 cars. Where we are with the project of the next 2 years cars?
Yeah, it is, as you say, a bit of a particular situation now, because we have 3 car projects on the go. We have the 2012 car, which obviously, as I mentioned earlier, needs to continue developing aerodynamically until the end of the season if we want to be able to challenge for the championship. And we have the 2013 car, which is, from a regulation point of view, an evolution. The rules are fundamentally very similar. So the work we do on the aerodynamics of the 2012 car will be also applicable to the 2013 car. But for the 2013 car, we already have a few people who are working on some general car layout issues on the main mechanical components, because there are some areas where we feel we can make a step forward compared to the 2012 car. So that's normal operation for 2013. Added on that comes, of course, 2014, which is a complete rewrite of the rules. Obviously the engine is completely new from every aspect, and there's a big group of people on the engine department working on that. but the rest of the car has some fundamental changes mechanically and big changes aerodynamically. So in order to come up with the overall car package that is integrated and competitive, we have had to put admittedly a small number of people, but just a few, who are already working on some concepts in order to be able to do this preliminary evaluation.
What happens to a race car from one Grand Prix to the next? To get a better understanding, we closely follow the journey taken by a front suspension arm from the moment it is dismantled to the time when it is put back on a car. Taking us through the phases of this journey are Diego Ioverno, Head of Assembly and Track Activities, and Davide Seletti, Head of Composite Production Department at Gestione Sportiva.
At the end of the event, the car is brought back with the Scuderia truck, and in the factory is completely disassembled because the components need to be checked and serviced.
After each event, the cars are disassembled at assembly car department. The suspension components then are brought to the composite department in what we call race-to-race area. In this area, the suspension components are visually checked to assess if there are any damage due to race use because of stone damage or something that can happen at a racetrack. After this inspection that assesses that visually the component is okay, we do NDT inspection with ultrasonic inspection. And this means that with this equipment we can check that there is no failure or damage inside the material where the eye cannot assess if the component is right or not. After this, the suspension components are brought under a machine that assesses the stiffness of the component. So given a certain load, we have to check that the stiffness of the component is the same as it was new. And if these tests are concluded positive, then we can bring back all the components for the assembling to assembly vehicle department for the next race.
After the check and the servicing, all the components are brought back to the assembly department, where the car is put back again and is charged on the track to be used in the next event.
Also in this edition, we continue our alphabetical section. New letters and new meanings explained by Scuderia Ferrari technicians to provide a better understanding of the complex world of Formula One.
Downforce. A Formula One car generates a lot of downforce. What is it? Well, it's a vertical force that pushes the car down such that we can go faster and faster around the corners. So more downforce, the quicker the car can go around the corners. It's generated with the same concept that an airplane flies and stays up, but it's the opposite effect in the sense that we have like here we have a wing profile. As the air goes through, it creates a low pressure underneath and just pushes and acts downwards and keeps the car on the ground.
J as jack. The jacks are used to lift up the car, both in the garage, both in the pit stop. This one here is a rear jack that is used to lift the rear of the car through the hook that is in the crash structure. And at the end of the pit stop, we release the car using this handle.
Pitch is the motion of the car, the front of the car going up or down, under braking, under accelerating. That affects the aerodynamic characteristics of the floor and of the front wing. Also, the ride of the car is affected. So the normal, when the car's running on the track, the car is normally, there's a bounce frequency, which is the car moving vertically, and pitch is the car oscillating front to rear.
the ride height of the car is the amount of millimetres it is above the ground. In general, the car is slightly raked. It's something like 80 millimetres at the rear and 20 millimetres at the front. Now it's defined by, if I turn the model upside down, the number of millimetres the car is off this plane of the car, which is always flat, at the front wheel and the rear wheel centre line. So it's a bit of an arbitrary number because in fact we don't have any bodywork here and there's no car here. There is at the rear but not at the front. So when the engineer is setting up the car, he's talking about the ride height at the front of something like 20 millimetres and something like the rear of 80 millimetres. Now that is very, very important for the performance of the car, because the lower you can go with the car, the faster it will go around the track. So every 10 millimetres you go down, you'll go about half a second a lap quicker, which is, everybody might ask the question, why don't you run the car on the ground? The problem is that if you run the car too low, the driver complains because it's hitting the ground and it makes him go slower. So you have to set it high enough such that it doesn't hit the ground as it's going round. Because as it's going round, basically we're generating downforce from the front wing and the rear wing. And these push the car into the ground. So we have to keep the car off the ground at all times. We use the springs on the front and the rear, and we use the tyre pressures to do this. So even if we had solid springs on the front and rear and made the car fixed, the tyres still squash into the ground. So it's a very, very powerful tool for the engineer to set the car up. If we get it wrong, the driver complains because he can't see where he's going because he's hitting the ground, and the bottom of the car gets very hot.